Welcome along. So today is a bit of a personal tale with a little bit of dramatisation about things I've learned, and my hope is that you'll take away one thing, possibly two, that you can apply this coming week. And if you have anything that you think, oh, what did he say about that? My website link is at the on the last slide, and all of the slides are up there, so you can go back and look later. My first computer was a ZX81. My parents bought it for me in 1982, and it was pretty cool. I had the big model. This is the 1 kilobyte edition. The big one had 16 kilobytes of memory, and it was pretty cool, and I had a lot of fun. But my parents were so mean because they refused to buy me any books. Instead, they bought me this thing. This thing is the Sinclair Learning Lab, and it was a programming course about computers in general and how to program the Sinclair basic language that came built into the ZX81. So I thought, well, how hard can it be? I'll make my own games. And so in a very real way, my parents have got a lot to answer for. Now, just as an aside, storing things on the ZX81 was done on cassette tape. You had to have your own cassette tape player, and you played them back and you record them, and you had to tinker with the bass and the treble to get it to work. How many of you have any device in your lives that can play cassette tapes? Hands up. Now, keep your hand up if it's not in your car. Cassette tapes have almost gone, and using cassette tapes for storage has well and truly gone. At high school, programming on Apple IIe machines, AppleSoft Basic, 6502 machine language, CP/M, Z80, UCSD, Pascal, I got right into it, and I played lots of games. I was clocking up 19 hours a week in the computer room on top of going to all of my classes. Obsessed? Yeah, I was obsessed. I went to Canterbury University. I got a degree. I worked at Apple as a hardware software technician. In 1997, I'm reading my slides wrong. In 1997, I started a career as a full-time professional software developer in Delphi. Loved it. 2004, shifted into .NET. I worked for the Reserve Bank of New Zealand for almost 12 years. Now I work for Microsoft, and I've got the coolest job in the world. I'm writing code every day for Azure. So what? Why did I just tell you this? I've been coding for 34 years, and I tell you, that's a truly scary number. How can I be old enough to have been doing anything for more than 30 years? Shouldn't I be good at it after 30 years? Or at the very least, shouldn't I think that I'm good at it? Well, actually, a few years ago, I felt like a muppet. I felt like I was just no good at this. And I had this very real fear that I was going to end up unemployable, that someone was going to call my bluff, and all of a sudden, that would be it. I was in a pretty dark place. I was not happy, and I wasn't enjoying what I was doing anymore. One of the reasons that I was upset and despairing was this. This is a graph from Steve McConnell's famous book, Code Complete. Hands up if you've read it. Okay? If your hand's down, you need to read it. It's a classic. The second edition that he put out is very, very good, completely relevant, and it will make you a better developer. If that's the only takeaway you take away, then that's a good thing. This graph is talking about how it gets more expensive to fix a defect the longer it is in your code. You know, we've all done this. If we write something and we find it's wrong within a minute, we fix it and it's cheap and we move on. It can literally be 100,000 times more expensive to fix something in production than at the requirement stage. Now, if you think about it, 2,000 hours is a person year of effort. So something that an analyst might have fixed with an hour's more effort in analysis can take 50 man-years worth of effort to fix in production. That's kind of scary, and I thought I was on the wrong end of that scale. So that's where I was. And I didn't want to be there. I wanted to go somewhere else. But I didn't really know where I wanted to go next. Then I realized that I wanted to get back to the puzzle solving. The puzzle solving was one of the things that got me into computers in the first time. Understanding a problem and trying to teach the computer to do what I wanted it to do. And that's so much fun. Isn't it? Yes, feedback. So I wanted to get back to the sense of competence about problem solving. And I wanted to feel like I was good at it. Now, I wish I could tell you that it was a straight, simple road, that I was in one place and I went that away, and after 3 weeks' work, I got to a better place. Well, no, it wasn't like that. There were lots of missteps and things I tried that didn't work for me. It was very much like walking through a maze and making wrong turns and backtracking and getting lost and getting found again. So, the first thing I did that worked was to start tracking my time. Because I was busy every day. I was working substantial hours. I'd get in and I was going full tilt all day. I'd often skip lunch, end of the day. I'd walk out, catch the last bus home, and I'd do the same day after day after day. Yet, I never felt like I was getting anything done. And so, like a good data scientist should, I needed data. What was I actually doing? Because I felt like I was walking out each day having achieved nothing. I found the emergent task timer. This comes from a guy by the name of David Say, and he's got this whole thing called the printable CEO. His idea is that the purpose of a chief executive officer is to set policy and process and direction for the company. And that by setting that, everyone is going in the right direction. So he's a solo guy. He works for himself. He does things for people for money, like most of us do. And so he sits down and he defines his policies as the CEO. He puts on the hat, does that, and he creates guidance for himself in the form of forms that he uses to run his business. Quite a smart way of doing it. So I use the emergent task timer. Each column is 15 minutes. Each row is a different activity. And so every 15 minutes, you just color in one of the bubbles to indicate what you were doing at that time. Then at the end of the day, you've got this visualization that shows you what you were doing. So anyone got some guesses about where I was spending almost all of my time? Kirk says email, and he's dead right. Okay, I'm a software developer. I deliver software for a living, and I'm spending most of my time in Outlook. This was not right. Now, there's times when all of us need to provide a quick response. But I was providing a quick response to every single message that came in. And I didn't need to do that. And worse, I had trained everybody around me to expect the quick response. So when I stopped giving them quick responses, they thought something was wrong, because I had trained them for years to expect Bevan's like this. This is Scott Hanselman. He's a smart dude. He has a podcast and a blog full of interesting things, and he's a regular speaker. At the 2012 Webstock conference in Wellington, he gave this presentation. It's not what you read, it's what you ignore. It was all about productivity tips. It's available on Vimeo. There's the link. If you haven't seen it, go watch it. It's really, really worth your time. And his well, the conference is full of good information, but one of the things I really took out of it was this quote about time travel. And I realized this was what I was doing. Every time my email toast came up, I'd start responding to it, and all of a sudden it would be 3 hours later. And the bit of code I was working on, I'd completely forgotten what it was supposed to do, let alone what I was in the middle of writing. So Scott's advice is that you deal with your email at specific times of day. If you live in your calendar, book it as a meeting of one. Do it the first thing in the morning, do it straight after lunch, and don't look at it the rest of the time. He even suggests closing Outlook completely so there's no toast. I'm not actually that brave. I do still leave it open. But I try to ignore my email, and I try to only look at it at particular times. He has 4 pieces of advice about something that's in your inbox. First thing you can do, you've read it, you don't need to do anything, you delete it. Done. If it's something that's going to take you 2 minutes or less, do it on the spot. It's not worth the overhead of trying to track it. Just get it done. If you can give it to someone else, then do it. Get rid of it. And when you've done those 3, you're left with the things you need to do. But don't do them while you're dealing with your email. Move them to one side and do them when you're doing tasks, not when you're doing email. So I applied this, and it started getting on top of my email. Then I noticed something else. I used to write long emails, explanatory novels. You know, we had a production outage, and we got it fixed in 20 minutes. Here's the breakdown, the analysis of what was going on and why it went wrong and what we're going to do to fix it. But people don't read those things. I once went for an entire week after sending out one of these long missives, getting questions in from all sorts of people about the outage and what was going on. And I was replying with quotes from my original email message. My boss wasn't entirely happy when he found out that was what I was doing, although he could kind of understand where I was coming from. So, since writing long emails is a waste of time, I don't do it anymore. Here's a website for you. Easy to remember URL. The idea here is that if you can't write it in 5 sentences, it's not an email, it's a conversation. Walk over to the person and have the conversation, and then maybe you come back and write something longer than 5 sentences to summarize the results of the discussion. Now, I'm long-winded. I can pontificate for ages, as anyone who's had a deep and meaningful conversation with me can attest. You know, Kurt gives his hands up. You know, I like having these conversations about things. So 5 sentences, for me, that's a real challenge. I've really got to pare it down to the essentials. If you're briefer than I am, then try 4 sentences. There's sibling websites for 3 sentences and 2 sentences if you're really brave. So, applying these, I had my email largely under control. I'm not going to claim I'm perfect, but it was much better. It was corralled, it was time boxed, and I was spending a lot more time in Visual Studio. So I was instantly a lot happier. But it was only a start. So this guy is David Allen. Not to be confused with Dave Allen, the comedian, although this guy is sometimes funny. David Allen has built an entire practice around getting things done. He's got this big consultancy where he will come in and one of his consultants will spend a week with you getting you organized. He reckons that most executives, most managers have around about 150 projects on the go at any one time. It's a scary number. But his basic premise is very, very simple. So let me illustrate what this means. Imagine your brain is a jar, and it's full of the things you need to keep track of, and how the screen's going. Actually, you can see the jar all the way to the top. These are good quality screens. On some of them you can't see that. So this is your brain, and it's got the production fix that you're working on today. And it's got that half-completed feature that you put to one side because production fixes take priority, of course. And it's got the fact that there's a change freeze next week for the next rollout. And so you've really got to get back to that feature, but you've got to get the production bug done first. And you're supposed to buy some groceries on the way home, and there was milk and there was cheese and there was something else you need for dinner, but you can't quite remember what it is. And you know that tonight you're taking your daughter to Scouts, and so you've got to get home in time to have dinner to get her there on time. And so, you know, look at the headspace at the top of your brain. You've only got a fraction there. You've only got a little bit of headspace to actually do the thing you're doing right now. Imagine what happens if you can reduce what's in your brain. You can literally be 5 times smarter just by getting all of the stuff that's distracting you out of your brain and putting it down somewhere. Now, there's a catch. There's always a catch. You have to trust that the system you use to write these things down, to get them out of your brain, you are going to go back to. Because you can't lie to your brain, and if you're not actually going to go back to it, your brain won't let go of things. But if you can find a system that works, and I've got some suggestions coming up, then you can defer things and stop worrying about them and be able to focus completely on the thing you are doing now. And that has real benefits for, you know what it's like when you're coding and you've got 12 things you need to keep track of at one time? Having a clear head's essential. Does this resonate with anyone? Lots of nodding, yeah, people getting distracted by what's going on. It's really, really common. So this is what I started doing. Now this is kind of old now, but this is really the to-do list from my notebook. I started keeping track of the things I needed to do. Now each one of these things was an action, something that I needed to do. So I didn't put something like plan a birthday party on the list, because that's a project. Call the bakery and get a price for a chocolate birthday cake. That's an action. And that's the sort of thing that would go on the list. So how did I make that work? Well, I stole this system. There's lots of things online. I stole this thing. You can steal it too. Everything on the list, just a dash, list the item. Dash, action, 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 action. When they're done, turn it into a plus, and then I can see that it's done. If I cancel it, put a line all the way through. And you can delegate backwards and forwards. And in that example I gave of getting a price for the birthday cake, you know, you turn it into a little diamond, triangle, and you can write the price next to it. And the triangle stands out when you're scanning through the list, so it's easy to go back and find that price again. And of course, your to-do list, you get most things done, you don't get all of them done. So you consolidate the list down. When you carry them forward, you use the circle so you can see which ones you've moved forward. This works. I've used it for years, and it's great. But I did find one small problem with it. And the problem was, it'd be the weekend, I'd be doing things with the family, and I'd be reminded of the 70 things I've got going on at work as I scanned through the list to try and find the things I was supposed to do at the weekend. Because, of course, we spend most of our time at work, and it dominates the to-do list. So what I started doing is I started using a Kanban board. This was just an A3 piece of paper with some headings on it, on one of those old copy stands that people would put documents on when they were doing the typing copy thing. And post-it notes for the things. And there's really something quite satisfying about moving a post-it note from the doing to the done column. It's a silly little psychological thing, but it's quite rewarding. And it gives you a sense that you're getting through things and you're actually getting something done. And there's an interesting thing with this. I came back to my desk one day, I was working at the Reserve Bank, and I found Tony standing at my desk. Now, she was my project manager on one of the projects I was working on. And she was having a look at the Kanban board. And I said, "Hey, Tony, how's it going?" And she said, "That's fine, cool." And she wandered off. And I was scratching my head for a few seconds thinking, what just happened? And then I realized my project manager had just gotten a complete update on what I was doing without me needing to do anything. 0 time. That was cool. Another time I came back to my desk and found that another post-it note had been put over the top of every one that I had made, and they all said the same thing. And it was Tony's handwriting. And she was just making the point, I want you to be working on this. And she didn't move anything or destroy any information, but it was just over the top of every other one. Now, I did say you don't put projects on your to-do list, and you don't put them on your Kanban board either. They have to be actions, things you can do and mark as done. So this is what I use when I have small projects. You know, it doesn't have a project manager. It's just, here's 10 things I need to do. So this comes also from David Say's website, and it's based on the idea of the cooking orders that you have in cafes. I don't know if you've seen them or not. They'll take the order and it'll go up and the chef will stick it on a rail, and it's his list of things to do. And as he moves the meals through the process of preparing them and plating them and having them ready for the table, it'll move along the rail. You've seen that? Yep, lots of nods, good. I don't have a rail. David Say says you've got to have one. I've used the edge of a bookcase on occasions, just tucking them under the edges of the books and lining them all up. But the thing is, just the process of listing out everything I need to do for a particular little project, getting ready for a conference, preparing a talk, things like that, helps me plan. And then I can consolidate and say, okay, I've done that, done that, done that. These things go onto my to-do list. That's good. I'm working through them. Keeps me on track of what's happening. And it's really easy to add things if I've forgotten them. Maybe one day I'll get a rail. I'll splurge. Now, here's the thing. I've learned something really, really fundamental from using to-do lists and Kanban boards and project planning and things. I'll tell you what I've learned. My brain's leaky. I forget things all the time. I'd have the situation of my boss asking me about something at work. Oh, when are you going to finish such and such? And I'll say, oh, you'll have it by the end of the week. It's going well. And then I'd go back to my desk and I'd open that thing in Visual Studio where I'd forgotten it and it was half done, and I'd finish it off. Okay? I'm going to ask how many people have done that because it's embarrassing, but I did that. And so by keeping track of things, I became a lot more reliable. I was able to deliver things on time. I was able to keep the promises that I made. And that's quite important. You know, if I commit to doing something, I really want to deliver and actually follow through. Equally, people at work have learned that if I'm not going to commit to doing it, there's a reason. And that becomes another interesting conversation. So, where am I at this point in my journey? My email is under control. My to-do list is under control. I know what I'm doing with my time. I'm spending most of my time in Visual Studio. Yay! I'm a geeky programmer. I make no apologies for that. My Twitter handle is The Unrepentant Geek. There's a reason for that. I still didn't feel like I was doing well enough, though. Still felt like I was having issues with too many defects in my code. Remember the graph from Stephen McConnell that I brought up earlier? So I didn't stop with realizing I had a leaky brain. I kept working on. So what I want to talk about now are some of the things I've learned about debugging my own code. Anybody know who this is? I gave you Scott Hanselman for free. You've got to guess this guy. He has impacted you every day as a developer, if you write code. This is Brian Kernighan, co-author of the C programming language. He's the co-author of the original Unix. So his decisions and design in the C language and Unix impacts us all every day. Famous quote from him. Debugging is twice as hard as writing code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. And I've been there. I've written a really clever bit of code, and I've come back 3 weeks later to debug a problem, and I've looked at it and thought, what the heck was I thinking? So what I started to do was I started to keep track of all of the bugs that I was creating. Now, I'm not talking about logging them in Jira or fog bugs or TFS or anything formal. Just a piece of paper, write down a few words to describe the bugs as I found them in my code. So this is a really interactive thing. And because I wasn't going to show anyone, I could be perfectly honest. And this was really interesting. Can you, oh, I was about to skip a slide. So I found 3 important questions to ask about every bug. The first question is, what is the bug? What actually went wrong here? And I'm not talking about getting a null reference exception. I'm talking about things like, I didn't check that I had valid parameters before I started using things. Or I didn't check that this was, I wasn't validating the inputs I was getting from the user, or whatever it was. Why did that problem end up in the code? Now, this is deeply challenging. This is one of the reasons why you don't want to make your list of bugs something that anyone else can see, because this can be really challenging to be honest with yourself about why the bug is there. Now, it's easier when it's somebody else's code, but mostly we're working on our own code, because, of course, as soon as you change it, it's yours. And then the question becomes, how can I avoid making that error in the future? So can you guess what I found, what I identified with the bugs that I was creating as I was writing code every day? I was creating the same bug over and over and over. I kept making the same mistakes. Now, that was kind of slightly soul destroying in one way, but it also meant there was easy gains here. This was low-hanging fruit. A few simple improvements to my own processes, adopting new habits, new practices, being aware that I was prone to doing this sort of thing, and my code got a lot better, a lot quicker. For me, one of these recurring mistakes is paying attention to the happy path. Does the right thing happen in the right circumstances? Straight through, correct answer, perfect. But what about the validation for when the wrong inputs come in? What about null reference exceptions for when things are configured wrong or just configured differently? What about the logging and diagnostics? So when it's misbehaving in production, we don't need to install Visual Studio on the production server to debug it. I have done that once, and I felt bad doing it, but it was the only way to solve the problem. And of course, if you're deploying into Azure or AWS or something like that, you might not have the option of putting Visual Studio on the box. So, all right, FaceTime again. Who's this? Somebody? Linus Torvalds. He's the leader of the Linux project. He's the creator of Git. He's on the record as saying his most successful projects seem to be named after him. The contribution guide for Linux includes this statement. And the idea is that if you've got more than 3 levels of indentation in your method, it's too complex. There's too much going on. Now, the worst method that I came across was a bit of old code from the Reserve Bank. It's no longer there. I got rid of it. It was more than 1,000 lines long and 17 levels of indentation. I look back now and think I should have preserved that as evidence of some great crime. That's a lot of levels of indentation. You think about Visual Studio with 4 spaces, you're talking 68 characters of spaces at the start of each line. 72 once you got the namespace, 76 once you got the class as well. So This is not why we have widescreen monitors. So both of these guys are making some very interesting points that simple code is the best thing to do. So what I started doing was I started trying to solve things in a clever way, and I started working on solving things in a simple way. Yeah, this was kind of hard because I like writing smart, complex code. I was clever enough to make that work. But that's actually not a great thing for production code, especially at work. I might still do that in my own code at home, but I sort of corral it off where it's not going to hurt anyone long term. And I have come back to code I've written at home and thought, what was I thinking? So simple code is a good thing. There's an interesting thing that I've spotted. There's been so many times that I've had a bug in a production system, and I've gone and there's been a really complicated bit of code, and I've been able to replace that with simple code that does the same thing and fixes the bug. Has better metrics, easier to understand. Some of the time I wrote the original complex code, and sometimes I didn't. But doing things in a simple way works. So let's talk about tooling. It's not often we spend our time coding in Notepad these days. Even if you're working in interpreted languages like JavaScript, Python, Ruby, there are IDEs and tools that can help you out. First thing I want to talk about is using your compiler if you have one, or a linting tool if you are working with an interpreted language, using it to work for you. Every compiler or lint tool produces different levels of messages. And my suggestion to you is you should target getting rid of every single warning message. And the reason for that is very simple. If you do a normal build and you get 998 messages streaming past on screen, that's cool, I guess. But then you make a change and suddenly you're getting 1,000 and there's 2 more. Are you going to notice? 2 more out of 1,000. You're not going to notice the extra ones. And you're not going to, therefore, decide whether or not you need to deal with them or not. If your code base has 0 warnings coming out, then getting 2 popping up is going to be dead obvious. And you deal to them and get rid of them. Now, if you're working on an existing code base like most of us are, turning on warnings can be daunting. What do you mean I've got 10,000 warnings and it stopped telling me after that because I got tired? You can always do things to get it under control though. Code analysis is another way to get warnings and messages about your code base. In Visual Studio, it's helpfully called code analysis, different names for other tools. This is about tools that are doing static analysis of your code base to identify issues, to warn you about potential problems. They'll usually talk to you about good practices and say, hey, you're doing this way, there's a better practice to do it that way. You can also add your own into the system. Now, if you're using a tool for Visual Studio like ReSharper, in ReSharper you can easily add your own warnings and things to the system. And then that can guide you towards getting down to zero warnings. Now, one of the issues that people complain about with code analysis is that when they turn it on, they get all these warnings. Well, you can tune the system. At the Reserve Bank, I was working on a system that had 20-something users across the bank. I could go and talk to every single user of my system. Can't do that for Azure, it's just a little big. But I could go and talk to them, and they were all in the building. So I didn't need to worry about globalization and localization. So all of the warnings that I was getting out of code analysis for those, just turn them off. Don't need them. But other warnings about, there's a code path that means this could be null and you're not checking for it, things like that, helped me improve the stability, reliability, and the logging in the system. one of the things I found was that the best thing I can do with the system is leave a good-looking corpse. If it's going to crash, fine, but at least I can leave enough debris lying around that I can come along like a forensic investigator and solve the crime. It's easier to solve a murder when you've got a body. I did once have a problem where the program was running and it would just vaporize and it would disappear. No Dr. Watson, no event logs. It was just like the process evaporated. And that was kind of fun to try and troubleshoot. Another thing to try, code metrics. Metrics is just a fancy word for measure, of course. So this is talking about ways to measure the content of your code. One of the classic ones is cyclomatic complexity, which is just a measure for how many different paths there are through a method. Higher cyclomatic complexity, of course, is harder to understand. Visual Studio has an interesting one built in called a maintainability metric. Now, it combines three concepts. Cyclomatic complexity, the more complex, the more paths, the less maintainable. Lines of code, longer methods are less maintainable. And something called the Halstead volume. Now, the Halstead volume really is just a measure of what sort of vocabulary do you need to have to reason about this method. So if you've got a really long method that just does for-operation arithmetic, you don't need a big vocabulary. You've got a 12-line method that interacts with 22 other classes. Then you need to understand all these other concepts to understand what this method is doing. So higher vocabulary means harder to understand. And the maintainability metric is really, really useful. Now, if you like it, you can get a gizmo from Microsoft Research that will run that analysis from the command line. And then you can include it in your build. And you can start producing graphs. And you can highlight subsystems that have maintainability issues, and you can start targeting them. None of this, there is no silver bullet. None of it's a guaranteed technique to make your system perfect. But using all of these things can help you move towards a more reliable, a more maintainable, a more monitorable, more supportable system. And that keeps the boss happy. And that's got to be a good thing, right? So let's talk about code. How can we write better code? Got a bunch of ideas here for you to think about. First one, keep it dry. The don't repeat yourself principle. The idea is that in your system there should be one source of truth for a particular fact. And if you need to maintain 2 parallel or 3 parallel or 4 parallel things and keep them exactly in sync, you've got a problem. So as much as you can, isolate things down that there is one source of truth for each fact in your system. Sometimes this is easier said than done. In a couple of places at the Reserve Bank, I couldn't achieve this, but what I did do is I wrote unit tests that verified that this thing and that thing were consistent. So if I screwed up the maintenance, changed one without changing the other, or if somebody else did in future, then the build would fail and it would tell them, hey bozo, you need to do both. The solid principles. If you're not familiar with these, Google them. They're important. They're not enough in themselves. So you've got the single responsibility principle, the open-close principle, the Liskov substitution principle, the interface segregation principle, and dependency inversion principle, and I didn't remember those off the top of my head. They're on my screen. Each of those can be a full 90-minute, 2-hour presentation all by themselves, so there's no way I can give them justice here. Check them out. They are helpful. Idiomatic code. Now this is not idiotic code, that's a different thing. So this is about writing code in the way that's expected for the platform you're writing in. So if you're a C# developer moving to JavaScript, you're bringing a whole lot of C#.NET isms with you, and you can end up writing some very strange JavaScript. Let me give you an example of what I'm talking about. Here is one way to loop over a collection of properties. Now it's written as C# code, but this is a Delphi idiom. In the Delphi environment, you would have an indexed collection for getting at the properties, and you would have a separate property with the same name suffixed with count to tell you how many there were, and you'd do a for loop to loop over them, get everything done. Any C# developer who's competent is going to come along at this and think one of two things. They're going to think, that last guy was a bozo. Or they're going to think, the last guy was smart, so he had a good reason for doing this. And they're going to dive down the rabbit hole to try and work it out. And when they can't, they're going to come up and say, that guy's a bozo. Of course, in C#, this is the idiom. You just use a for each loop. It's a collection, it's enumerable, and it just works. I saw something like this that was written in Delphi style in Java many years ago. And the thing was that in the Java code, in the Java idiom at the time, when you accessed a list, it would always return a copy of the list from the object so that you couldn't monkey with the internals. So that means in this collection on screen right now, where it says properties and it starts to index it, every call to that was getting an entire copy of the list, indexing into it once and then throwing it away. So all of a sudden your loop that should go through an order n time was taking order n squared, and performance was terrible. Using local idioms is important for performance and correctness as well as intelligibility. Primitive obsession. This is about using strings and ints and doubles to pass around information when there are better types or when you can create better types for passing around that information. So here's an example. This is some sort of a document and you're going to save it to a file and it takes a string. Who's written code like this? I have. But it takes a string. So you could pass an address or a username or a phone number. And because those things tend to be valid file names, you'll end up with some strange files created in a strange place on your disk. And it's just, you know, you've got to see that at runtime and work out what's going on. If you instead used a specific type, like the .NET type file info, to say, this is the file I want you to save in. Now, file info doesn't have to represent a file that's already there. You can just new it up to point to any file you like. But there's no way you can pass a string here, so you can't pass a username or a phone number or a URL, and you can't have funky things going on. It's also quite clear where it's not here. Would you expect that to work if you gave it a URL? Would you expect that it was smart enough to do a post to some web service and send the file? Possibly, yeah. It's dead obvious from this one. This is going to your file system. It ain't going anywhere else. Associated values is an interesting one, and I see this in code bases that have evolved over time. It creeps in. And what's happening is that you've got a bunch of collected, of associated variables that are always used together. You know, maybe you've, all the way through your system, you have first name and last name, and it goes through and it's in 75 or 100 method names, and now you need the honorific as well. So you get the job of modifying every one of those 75 or 100 methods. So now you've got first name and last name and honorific. And then somebody tells you, well, that's actually not very good. That's very Western. You actually need to have family name and full name and known as and honorific. And you've got to go through and completely rework 75 or 100 methods for the change. And for most of those methods, they won't actually care too much. This is crying out that there's actually a class or a record or a struct or something in your system that you haven't brought out as a separate concept. If you do that, then all of a sudden it becomes much easier. You need to, you've got that honorific, you need to add some sort of a suffix to support certain names in your system. And you can add it to the object and you don't need to change 75 or 100 methods because it's just this object that's being passed around. Now, parallel lists is another one that I've seen. And for some reason, I've seen this a lot in MATLAB code. I don't know what it is about MATLAB as an environment or the culture or whatever else that encourages this. This is where you use 2 or more parallel arrays or lists to keep track of related things, where the thing at index 10 in each list is related to the index at 10 in all the other lists. So you can imagine putting together a Christmas list this way. So you make a list of, these are the people that I'm going to I'm going to give Christmas presents to. So you got Susie, she's 7. She's your niece. And you got Granddad, and Uncle Jim, and Uncle Tony, and so on. And you put some thought into it, and you come up with a list of gifts you're going to give them. And Susie's going to get an Xbox game because she's really into those things, and it's an easy gift. And Uncle Tony, you're going to buy him The Sopranos because, that was just good. And Uncle Jim, because you always buy him a bottle of Jim Beam, and he just loves it. And it's easy. And you can pick it up at duty free on the way through the airport so you don't have to carry it too far. But of course, these are separate lists. So what happens when you sort one of the lists of names? I don't think Granddad's really going to like getting the chew toy. And Susie's only 7. I'm not sure what she's going to do with a bottle of Jim Beam. Now, of course, the solution here is you have one list with multiple columns. In C# you have a list and an object with multiple properties. Other systems you can do it in other ways, but you make sure that you don't have these lists running in parallel. Now, I had this exact problem where a list of things was showing up on screen in the user interface, and they were coming through in natural order, the order they'd been created in the database. Because nowhere was it being sorted. The SQL query was pulling them up, and it was getting hydrated on objects. They were coming across the wire, rendered in the user interface, and they decided they wanted them in alphabetical order. So I found the right spot, and I sorted the list, and that was good. I ticked it off. We deployed it into production, and we found that everything was broken because this parallel list thing was going on. So I had to go in and create the object and get rid of all the parallel lists, and this simple fix took me a while. Immutable types. Mutable types can be your friend. Seriously. They're simply types where you can't change an instance once you've created it. Now, it might sound limiting, but you can actually do everything you do with mutable types with immutable ones. And you gain things like reusability, lock-free concurrent access. Facebook have done a bunch of stuff with using immutable objects in one of their systems, and they found it was 30% faster to use immutable objects in a C++ system. Now, this was particular to their use case, but they had less memory management, lower memory use on the system, which meant they could keep more in memory, there was less swapping of data, the caching worked better, and they had overall a 30% performance improvement, and that's pretty good. All of these things can be presentations in their own right, of course. Operation archetypes. So this is about the idea that certain methods should have certain purposes, and it's kind of a variation on the DRY principle of don't repeat yourself, that each method should have one responsibility. Sorry, that's the single responsibility principle from Solid. Got that wrong. So the idea here is that the methods in your system should be one of 3 kinds. You have queries that return information about a system, but don't change it. You can do the same query over and over and over and over and get the same result. You've got commands that change the state of the system. And if you are doing CQRS or certain kinds of concurrency, you want to make sure that your commands are what's called idempotent or idempotent. And the idea then is that you can do that command 1 time, 10 times, and it will have the same effect. And you can imagine there's certain things around accounting and financial institutions and keeping track of money. We're making sure that a transaction is done exactly once and only once is quite important. But of course, you need to combine queries and commands together, and that's where you get orchestrations. Now, this sounds all very highfalutin and fancy. Well, here's a very simple example. What do you think this method does? It checks whether a file exists. That's what it says on the can. That's what you would expect. So would you be surprised with this implementation? Now, this is written in C# and the original was in Delphi, but this was in production code. What had happened was there was caching code, and if something went wrong pulling the file down into the cache, it could come up with a 0-byte file. So in addition to trying to fix that bug, they needed it to recognize that if they had a 0-byte file, the file wasn't in the cache and it should pull it down. And some bright spark, and it wasn't me, I promise, decided to put that check and that delete in the file exists method. So you can imagine coming along a couple of years later, I was trying to troubleshoot something where I was getting an unauthorized access error trying to see if a file exists. What do you mean I can't delete the file? I'm not trying to delete the file. The problem here is that it's doing two things. It's both a query and a command. Okay, coming up on time, let's turn it to 11. Code reviews. There is nothing more humbling than getting your code gone over by somebody who is just as smart as you are, or smarter. It can be humbling, but your code comes out the other end much, much better. If you don't get regular code reviews done, do it. Now, it's a learned skill. You're going to screw it up the first few times you do it. And some people code review better than others, and some people take having their code reviewed better than others. I had to learn to accept that it was criticism of the code, not of me. Adam Kogan is a Microsoft regional MVP, and he has a company based in Sydney. And in his company, they introduced this idea that before a bug or feature can be signed off and released for testing, the developer had to record a screencast demonstrating the bug was fixed or how the feature worked. And you think, geez, that's a bit of an overhead. It cut defect rates by 30%. Because it forced, now they made it a part of the requirement in TFS that this thing was attached. You literally couldn't progress without it. I'm not sure I'm a fan of that. But it forced the developers to close the loop and do that final check. Now it's really easy to skip it. You know, you're under pressure. You've got 10 things to fix. You want to get it out by the end of the day because, you know, there's a release deadline. But closing that loop and checking. So I started doing this at the Reserve Bank, and it went really, really well. I found defects. You've got to write for the long term. What does this mean? It means we're creating business assets. It's not just about what you're doing today for this week's deadline or this next release. You're creating an asset that's going to provide business long term. Going to provide value long term. So we're used to thinking about our projects in terms of functional requirements and non-functional. I want to suggest that this is broken, and there's actually a third thing we need to be thinking about. We need to be thinking about the security of investment, the long term. It's not just enough to write the code that works now and is fast enough now. It's got to be done in a way that someone can come along in 6 months or a year or 2 years or 5 years and understand what's going on. Maintainability, extendability, understandability, and stability. You know, all of the ilities and things come into security of investment. If this thing goes wrong in production, does it produce enough logs that someone can troubleshoot the issue? You need to embrace continuous learning. We don't work in an industry where you can learn and then do for 20 years. If I look back over my career, every 5 years, my job is fundamentally very different. I'm still a software developer. I have been since before I graduated university. And I expect I will spend the rest of my career as a software developer because I'm that kind of geeky guy who likes to write code. But I do expect that every 5 years, my job is going to be substantially different. And so you need to be learning something new. And this doesn't mean going to a course every 6 months. Again, another entire presentation on that topic. If you're not embarrassed by code you wrote 6 months ago, you're not growing. Man, that's kind of harsh sometimes. My final tip, find a mentor. Now this could be someone who's more practiced than you. It might be a peer, might be the guy at the next desk, although going outside the org can be interesting. The idea is to have someone you can bounce ideas off, someone who can challenge you, where you can talk about this situation you're having at work where it's just so hard, and he can actually say to you, you know what, Bevan, you're being a bit of a jerk. Really? Someone who can talk to you, you can be honest with. Because our self-view is often distorted, particularly when we start comparing ourselves to others. You know, we see all of our flaws, and I see how cool Kirk is. He's nodding. Yep, he's cool. And is that valid or not? Talking to someone else can say, actually, no, you both got good points, bad points, whatever. This is Phil Hack. He works at GitHub. Until recently, his job title was Windows Badass. I'd love to have something like that on my business cards. His job is to spend all day doing whatever he needs to do to make GitHub awesome for Windows users. He gave a presentation at the very first CodeMania conference in 2012. And I'll slightly edit the title, but the title of the code was, I love to code. There was a profanity in there. He had another title that was work safe, but it was, I love to code. And this is me in my happy place in a more bearded time. Visual Studio is my happy place, and I really, really love to code. Any questions? Thanks, guys. Anyone brave enough with a question?
What about design patterns?
Design patterns, they did used to be very popular. They still are. In some ways, the value of them is still there, but the hype has gone away. A lot of the design patterns, especially the ones from the original Gang of Four book, are now basic fundamentals that people expect you to know. They're a very useful vocabulary. That was always one of the most valuable things about them, was to say, I think you need to be using the observer pattern here, or so on. One of the other things to keep in mind is that a lot of the original Gang of Four design patterns emerged from what we'd now call deficiencies in C++ and programming languages of that era. If you move forward into languages like JavaScript and Ruby and Python and Go and Rust and other things, they often have things built in now that make those design patterns obsolete. There are other design patterns around as well that are very useful to learn. So there's still a lot of value in them, and you should know them. If you don't know what a strategy pattern is, if you don't know what the state pattern is, observer, all of those, go buy yourself a copy of the Gang of Four book. It's really good reading. But you do need to keep it in its context, that some of them are not relevant for some of the newer languages because those ideas are now rolled in. Anyone else?
How do you deal with interruptions
So the question is how I deal with interruptions from teammates or other things going on. In some ways, I deal with it by being somewhat disciplined and keeping track of what I'm doing, so it's easy to return to a task. Sometimes I will deliberately block out the world and put on headphones. You know, there might not be any music coming through them, but it's a signal to people that I'm busy doing things. But one of the things I'm also that's also relevant to this is I've seen some research that came out recently about the impact of open offices versus everybody having their own office to work in. And the interesting thing there was that going open plan tended to have a negative impact on individual developers getting things done, but a positive impact on the team delivering. So it's like there's a sacrifice of a little bit of productivity per person because that effort's now going into interaction around teammates and things, and that has a net benefit for the team as a whole. Interactions are troublesome. You know, it can take half an hour to get back into what you're doing after a 10-second interruption. Getting into flow is a very real thing, and it's lovely being in flow and just getting stuff done. You look up and think, shit, I should have gone home 4 hours ago or an hour ago or something, and you know, you get stuff done. But the interruptions can have value as well. One of the things I do in order to get back on task fairly quickly is when I get the interruption, I'll take the time to write down a few words on a line in my notebook of what I was doing. And that serves as a memory jog when I come back on task. Oh, what was I doing? And I can read that, and that helps me get back to where I was more quickly. But there's always a cost to the interruptions. I guess what I'm saying is I've realized that often those interruptions have value in themselves. Possibly not the most satisfactory answer to your question, but anybody else? I'm conscious you, oh, here we go.
What happens if the interruption is actually from the client? Not through email, but other forms of communication.
Yeah, sometimes you can't put them off. Sometimes there really is a fire alarm going off and you need to deal to it. Sometimes production really is down. One of the presenters here at Ignite, I can't remember who it was talking about how he fenced off Thursday, Friday and Monday for code. And he booked it out in his calendar so that he couldn't have meetings there. And if somebody really needed a meeting, they'd book it. And then Wednesday and Tuesday were his meeting days, where he dealt with the fact it was chopping and changing all the time. Now, if you can train your client into complying with that kind of thing, that all works well enough. But there are some people for whom collaborating through the machine is not the way they work. There are some people who will insist on, oh, I've got this idea, I've got to talk to you now. And they will come and they will interrupt you. And sometimes you can train them out of it and sometimes you can't. And if they are the client who's paying you, then you know, maybe the interruptions are just part of the job. It's a real challenge, especially when you've got a deadline and you're trying to get things done. Anybody else? I'm conscious there's drinks and lunch and things, and that's it for the conference. Thanks, guys. I really appreciate you coming along.